I was inspired by a video from a gentleman named Ben Eater, where he takes a series of 7400 logic gates and so forth. And from that, he constructs on a series of 8 or so breadboards a simple 8-bit CPU. And what I thought was really nice about that video series is it provides an unparalleled look at the internal workings of a CPU, at least at a small scale, and provides a close look at each of the components and how those components work together to form CPU behaviors, and builds it up into a fully functional Turing machine. Now, one of the things that's nice about Turing machines is that once you have a Turing machine, you can use that Turing machine to simulate any other Turing machine. And so what I'd like to do is sort of continue the theme that Ben started, in that what I want to do is I want to take us through the construction of the Java virtual machine. So what we're going to do is we're going to start by laying out all of the pieces that go into a Java virtual machine. We're going to talk about them each in turn, and we're going to slowly build up to constructing our own Java virtual machine. So let's go ahead and get started. I'm going to start over here on the right-hand side with a data structure called the heap. And the heap is simply an area of memory where data can be stored. It might be the number 7, it might be a floating point number like 6.8, and it might be an object. Technically, this would be an object reference, or a character, or really any data type that we like. And the heap is organized such that every location in the heap has a unique address. They're not necessarily in any particular order, but everything that we put into the heap has an address. Now on the left-hand side, we have another data structure that's similar in that it can hold any type of data that we like. And this is called the stack. Now, what's different about the stack is that the access to the stack is only from the very top of the stack. I can push items onto the stack, and I can pop items from the top of the stack, but I can't really access anything really deeper than the very top entries of the stack. But what I can push onto the stack is anything. I can push numbers on there, I can push floating point numbers on there. Really any data type that we want to operate on, we can push and pop from this stack. But the important element is that we can only really access the very top of the stack by push and pop operations. And we'll see a little bit later on why that's important. The next important area of the machine is, I'm going to draw here in the middle, and this is sometimes called the method area. And what goes in this is a list of instructions. In Java parlance, they're called bytecode. In machine language, for other CPUs, this would be analogous to assembly code. So I would have instructions like a load, a push, an add, etc. And each of these instructions also has an address. And in order for the machine to keep track of where we are in the program, what instruction we're executing, we have a special register called the program counter. And this is exactly analogous to the program counter in an 8-bit CPU or really any kind of CPU. And this program counter simply has a counter that points us to the next instruction that we're about to execute. Now, methods need to operate on temporary storage, and for CPUs like an 8-bit CPU, the 8-bit CPU that Ben constructed, these were called registers. In the Java virtual machine, these are called locals. So the local area is where we put register storage. So this is temporary areas that the instructions may need to access in order to execute their instructions. And just like the stack and the heap, locals can store any type of data that you want to operate on. They can store characters, they can store integers, they can store floating points, and they can store object references, etc. And then finally, accompanying the machine instructions is a small area that's an addendum to that keep track of the exception table. And the exception table is really a series of jump instructions that tell us where to jump, where in the program to jump, and how to behave when there are any kind of exceptional conditions going on. And we'll talk a little bit more later on how that works. So next what we're going to do is we're going to switch over to the computer and we're going to start building this machine. And the way I'd like to structure it is I'd like to structure it as a JavaScript application. And what we'll do is we'll have a panel for each of these areas on the page so that we can see what's going on inside. And this is very much analogous to what Ben had done in putting LEDs on various points on the board, just so that we can easily see what's going on inside the machine. It would be perfectly possible to build the machine without any kind of user interface. In fact, most Java virtual machines don't inherently have a user interface. But since our primary goal here is to understand the internal workings, that's what we're going to do. We're going to build a one-page JavaScript application where each of the areas inside the virtual machine are shown so that as the machine operates, we can really watch it step by step and see everything that's going on when we move things from a local into the stack or push it onto the heap, etc. Now, this is just the data structures involved in the virtual machine. There are a lot of other ancillary data structures, and we'll talk at some point also about the garbage collector and so forth. But I think this is enough to give us a sense of how the machine is constructed. And so we're going to go over to the computer and start coding a little bit of this up. So we're going to start looking at actually building the application now. And I went ahead and got a quick head start just to get things structured. And what I want to do is just talk through all the different pieces that are going to play here. I'm using Bootstrap as the user interface set of style sheets, and I'm also bringing in the corresponding bootstrap.js from a CDN, so that's what that is. Also planning on using some jQuery just to give me some handy shortcuts for setting up the UI And I'm going to be making use of a split screen effect that's going to allow me to resize different pieces of the user interface. For the main part of the virtual machine, I've divided this up into 3 pieces. The first is just called JVM.js. This is really going to be the main, if you will, or the main body of the system. But then it's very quickly going to delegate most of its responsibility either to the user interface, JVM-UI, or the actual virtual machine, which will be the code for that. Is really where we're going to be spending most of our time focusing on. This is JVM.js. And I've also written myself a little custom style sheet just so that I can style the application the way I want it to. For the actual layout of the machine, what I wanted was a header at the top of the page that has a run, a stop, and a single step. This will allow us, when we get to that point, to interact with the machine and tell it what to do. We can either run continuously, we can stop it, or we can single step it. For the main parts of the virtual machine, we talked a minute ago about the stack, and so that's going to be up on the left-hand side. And then the middle area is going to be where we have instructions. And these are going to be the bytecode instructions that tell the machine what to do. So this is how we're going to visualize those. Then at the bottom of that instruction tab, we have an area for the variables. These are the local variables that are playing the role analogous to registers in a conventional CPU. And then I've reserved a place for output for I/O. We haven't really talked about how the virtual machine interacts with I/O, but wanted to reserve that as an area on the UI so that we have that later on when we're ready to talk about I/O and how that works in the JVM. And then finally, on the right-hand side, we have the area for the heap. This is the main memory where objects are stored. So we have an area for the heap. So if I go ahead and bring that up in the browser, I just point my browser to that index.html, and what I get is the header with the run, stop, and single step button. Of course, we haven't built anything yet, so these buttons have no effect. The area for the stack is on the left. In the middle area here, we have the area reserved for the bytecode. We have a tab at the bottom for variables and output, and on the right-hand side, we have the heap. And we've got this set up so that we can drag and resize these different areas. This will be handy, I think, later on when we actually go to use the system. We may want to focus on one area or another, and it's just going to be handy to have these little drag things so that we can resize and look at those different areas more closely. For the code that actually drives this, we talked about the main area, which right now is very minimal. Just has a document on ready function. So as soon as the document is loaded, we execute this, we create a new object that's this user interface object, and we call initialize on that. And that's pretty much all we do here in the main portion of the program. What that does is it uses some jQuery code to activate the tabs so that those tabs that we saw, the tab here, variables and output, the initializing that, this is the code that allows me to do that. And we have some code that activates the buttons as well. We're not yet linking those up into any handlers, so the buttons don't actually do anything yet. But this is the jQuery code that allows us to interact with the buttons. And then finally, we have these horizontal and vertical split objects. I'm not going to talk too much about them. You can do a Google search and look up what these are and how they work. But in summary, you just give them the IDs of the div areas that you want to be resizable, and the system automatically puts in those little handles and allows you to drag and drag them left and right. So I have one of those for the vertical and one for the horizontal splits. And that's really what the code that gives us this dragging behavior that allows us to drag these up and down or left and right. But the main focus of our exercise here is to build a virtual machine. And of course, we have nothing because we just started. So how I want to structure this is I want a virtual machine object. So I want an object that represents the virtual machine. And I probably want some kind of initialize function on that. But of course, I've created this new instance of this object and initialized it, but this object doesn't actually exist yet, so that's going to be a problem. So what we're going to want to do is come over here and create an object that represents that. So what I've done here is I've created a function called JVM that returns a new instance of itself. So this is how I'm modeling objects and constructors in JavaScript. And we said that we want this object to have an initialize function. So we're going to say object.initialize equals function. And it's really not going to do anything at this point. Now, the virtual machine, in order to behave the way we had envisioned it, we're going to need something that we call the stack, something for the instructions and variables, and something for the heap. I'm going to ignore output for now because I want to handle sort of the core of the VM before we handle the I/O. So what I'm going to go ahead and do now is I'm going to go ahead and create objects that represent each of these pieces of the VM, the stack, instructions, heap, and variables. So let's go ahead and do that. We'll call it JVM stack. JVM heap. We'll call it JVM instructions. Actually, let's rename that. According to the Java Virtual Machine specification, this is usually called the method area. So let's call it JVM Method, just so that we can align our terminology to what we'll see in the virtual machine specification. I should mention at this point, before we go too much further, that we're going to be referring to the Java Virtual Machine specification. And in particular, I'm going to go ahead and point to the JVM version 8. You can look this up on Google. Oracle publishes this specification And there are various versions of it that change. And all of the different areas that we talked about, the program counter that we talked about, the stack, the heap, the method area, etc. Now you may notice that we're skipping the runtime constant pool and the native method stacks. That has to do a little bit with some input-output considerations that we're not really going to be concerning ourselves for now. So for right now, we're really just going to be dealing with these first four data areas. But if you're curious about the JVM internals and the actual specifications, you can go to Oracle, and they have published the internal JVM specs. And we're going to be referring to this document throughout most of this video. So we have our stack, heap, method area, and now one thing you may have noticed that we skipped over here is the program counter. And the program counter is essentially just an integer, and I have to make a decision about where I put that. I could put that directly in the virtual machine, and that would be a reasonable choice. It seems overkill to create a separate object for it, so I really don't want it just an integer in the virtual machine. So it would be nice to attach it to one of these other objects, and the only object I think that really makes sense for it to be attached to is the actual stack. So what we're going to do is say var obj.pc, and we'll go ahead and initialize that to 0. So that covers all the main areas as far as creating objects goes. And the only thing really that remains is for us just to say object.stack equals new JVM stack, object.heap equals new JVM heap, and object.method area equals new JVM method. Now this is a vast simplification of the internals of a virtual machine, and as we go along we'll be adding quite a bit of nuance to this to make it fully compliant. But I'm going to go ahead and wrap it up here, and next time we will start to look at the method area and start filling that out a little bit more, and in future videos we'll build out some of the other objects. So that'll be all for today. Thank you for watching, and I hope you join me again next time when we continue this project. Thank you.